Welcome to this video about Modbus terminology. I was prompted to make this video as there's some confusion amongst customers of our software as to which software does what, and in order to clarify that, I've put together this little presentation to tell us a little bit more about the terminology in Modbus. We read master, slave, client, server, RTU, TCP, ASCII. There's so many different things in Modbus. So let's just go through it step by step, and hopefully by the end of the video you've got a much better understanding. Now, firstly, two basic, fundamental, different types of Modbus communication. Firstly, we have got the Modbus TCP IP, or Modbus TCP for short, where the Modbus devices are communicating via some type of network interface. And let's just say classically that could be an Ethernet type interface. And then we have got Modbus RTU, remote terminal unit is what it stands for, Modbus RTU, which uses serial interface. So that's the first distinction. We got to distinguish between Modbus TCP, Ethernet type network communication, and Modbus RTU, which is a serial type of communication. Now, when we have a quick look and we compare those two, this is indicating a bit of a protocol stack. We can see that Modbus TCP utilizes a TCP IP stack and has then got numerous hardware or transport mechanisms. Could be Ethernet, could be Wi-Fi, could be mobile phone network. And we've also got on Modbus RTU, the serial one, we are using a UART, which is a serial communications processor, and then the transport method is normally via RS-232, 422, 485. I'll also draw your attention to the different devices, the naming of the different devices. So in Modbus TCP, we refer to a client and a server. In Modbus RTU, we refer to a master and a slave. So let's just start with one of them. Let's start with Modbus TCP. Modbus TCP, here's a typical architecture, which is the standard Ethernet star topology, where we got a switch or a hub, and we have various devices connected in a star formation to the switch and the hub. So you notice here that we tend to have multiple servers, and we tend to have one, could be more, but normally one client. So that gives us a bit of an idea how the servers and the client are actually connected. There's various other types of network topology. There's ring networks and mixtures of networks. So all of those, basically, if it applies to an Ethernet network, you'll be able to get the TCP running over it. Here we have a slightly different topology, which is quite often used in industrial environments where a star configuration isn't always useful or isn't always practical. So it's a daisy chain. Now, a daisy chain is where we're going from one device to the next and to the next. And in fact, what these are, each of the devices has got a small 2-port hub built into it. So these are really a device with an integrated hub or switch. Again, we're seeing in this picture that you've got devices. These devices are referred to as servers, and then you have a client, and the client takes information out of the server or sends information to the server. So this is a typical industrial installation where a star configuration may not be suitable. Just to make sure that we've got that terminology clear, In TCP we have a client and we have a server. As you can see in this diagram, the client initiates a request to the server performs the action, and then the server initiates a response which is received by the client. So Modbus being a request response type protocol, the client initiates the request, the server responds to the request. So just to get that clear. Now let's just have a quick look at some of the way you can run it. And it is normally a full duplex operation because we've got Ethernet or some type of network protocol which can transmit and receive simultaneously. So because of the ability to do that simultaneously, we refer to it as being a full duplex. So there's another terminology that you will see, a full duplex communications protocol. Now let's have a quick look at RTU. So RTU, Modbus RTU, utilizes a serial interface as opposed to some type of network interface, and we have got the same sending a request, reading a response type system. That's what Modbus is. It's a request response protocol. We have the master shown on the left hand side here, and we have the slave shown on the right hand side here. So the similarity is certainly there to the TCP, but in the TCP what we're calling a client in RTU is called a master. So the device which initiates the request is called a master. The device which sends the response back is called a slave. We have got different types of serial communication. The most popular, and there's many different types, but just the most popular one that we've got here, the most popular two that we're listing here, is an RS-232 and an RS-485. Most Modbus installations would be utilizing an RS-485 or its derivative, the 422. You can see here a few differences, and they can be full duplex or half duplex. The maximum cable length, so 232 has got a fairly short cable length, 485 has got a much longer cable length. There's a difference in the data rates, and there's a bit of a difference in the way it's wired as well. So these are just some of the very basic differences between RS-232 and RS-485. Here's typically how it works. We have in this case we have a master, which is shown here as a computer, and quite often nowadays we are using a USB to serial converter, which we've showing here on the left hand side, and out of that USB to serial converter come these serial signals. So this particular one, you can see there's an A and a B, and that's the standard for RS-485. You have an A and a B. This one here is showing a shielded line coming out, but that's that can be either. You might also notice that the slaves here, and they're numbered 1 through to up to 32. So there's a certain limitation, because as one device is sending, there's a number of devices listening, and the listening devices are obviously all drawing current. So there's a limit to how many we can have out of one sender. If we need to have more, we can extend that, but we just need something on the side which is boosting the signal. Let's have a quick look at the simplified version of it. We have a master, we have 2 wires, an A and a B, and those wires are looped from slave to slave to slave. That's your typical RS-485 communication wiring, which is what you will find in Modbus RTU. A slightly different diagram that actually shows the master on the left hand side and the slaves on the right hand side. So always remember, it's a request response protocol. The master sends the request, the slave sends the response back to the master. And you can also see here that daisy chain type system. When we have half duplex communication, just to make that complete that part of it, it means we cannot send and receive at the same time. So this diagram here explains that the master can send something across, but you cannot receive back at the same time. Or you can receive, but then the master can't send. So there's some level of coordination required, and that's why most of those serial networks only have a single master. So the master obviously can then talk whenever it wants to. When there's multiple masters, it gets a little bit more complicated because they need to coordinate to make sure they're not sending at the same time. All right, that's a half duplex. We are also showing here an RS485, which is an extended version of the 485. The 485 interface receives and transmits on the same two wires. The RS422 receives and transmits on separate wires. So you can see the master, shown on the left hand side, has got a TX connection, and that is connected to the slaves, shown on the bottom, on the RX input. And then the TX output from the slave is connected to the RX input on the master. You'll also notice on the right hand side there's a termination resistor shown, so RS422 and RS485 normally have a termination resistor of 120 ohms. These resistors are fitted to both ends of the daisy chain. They're not fitted to every slave in between, but to both ends of the daisy chain. So here is a quick summary of the terminology that we're using and where it's applicable. So on the left hand side, Modbus RTU has a master and has a slave, uses a serial interface, is to a large degree half duplex. Most of them are half duplex operations. The interface method that we have is an RS232, an RS485, and an RS422. On an RS232, which is not designed to have multi-drop, so therefore there's only two devices. You can only have a master talking to one slave, and that's it. On 485, we can have multiple devices. That's got to do with the tri-state drivers. The length, as you notice, 1200 meters. That's quite a long distance that you can run a Modbus RTU signal. On the right hand side, Modbus TCP, we have got a client and we have a server. And notice the master in RTU does the same job as the client in TCP. The slave in RTU does the same job as the server in TCP. Normally we have a single master or a single client, and we have multiple slaves or multiple servers. On TCP, we have got it's a type of network interface without defining it exactly, because it could be fiber optic, it could be Ethernet, it could be Wi-Fi, it could be a connection that runs through the internet, where there's many transitions. It's full duplex, always full duplex, and you can always have multiple devices on it. So I hope that gives you a quick summary and a quick overview to clarify some of the terminology that is used in conjunction with Modbus, TCP and RTU. So just to make it very clear for the applications that we have, and these are applications that allow you to simulate Modbus devices, so we call it simulation software. And I'm going to put some links to that software below in the comment section. So for Modbus RTU, we're providing two packages, a Modbus RTU master and a Modbus RTU slave. You will require a USB to serial adapter to get that serial interface. On the Modbus TCP side, we're providing a Modbus TCP client and a Modbus TCP server. So if you are building yourself a device that needs to talk to Modbus devices, you can use the Modbus TCP server to simulate the device from your Modbus client. So typically, if you work with things like an Arduino or other programmable microprocessors that have got an Ethernet interface, they will be, your device is going to be the client, and the software you need to simulate the other device, the device that sits there, is a TCP server. And on RTU, of course, you need an RTU slave. So that is about all we have. If you have any questions, if something has been left unanswered, please leave some comments below, and we'll try and clarify all the points. Thank you for watching.